Hi everyone, my name is Yashwant. Welcome back Ash Academy. Today's video, we will discuss Kubernetes to the production level deployment in retail store application. Entirely it's automation to deploy this application with one click. I will explain the entire architecture and phase by phase. This project, I divided a total 4 phases. I will explain with step by step to entire project. Okay. This is our YouTube channel. This is our YouTube channel, Ash Academy. In this video, in this YouTube channel, I uploaded multiple three-track applications and SRE course in some AWS content and latest tools and everything I uploaded. If you go want to refer, happily you can go and refer this content. And this YouTube channel, few days back, I uploaded 11 microservices CI/CD DevOps project. In this project, total 11 microservices I deployed. Entirely it's automation with CI/CD pipeline with Jenkins. Entirely, this is the production level application. But today's, this is entirely Jenkins CI/CD. Now, today's video, similar type of project, but that's a retail store application we are deploying with 5 microservices. But difference between 11 microservices and 5 microservices means these 11 microservices entirely we used one language is Python language we used and front end React we used and database Redis database we used this application 11 microservices. But coming to the 5 microservices, we are using the multiple languages and multiple databases. We are using this application, 5 microservices. I will explain the architecture first. After that, you will get the clarity why you want to do this 5 microservices project. If you not done 11 microservices project, please go through the video and done the project. After that, you will come back to the 5 microservices because this is the base of the 5 microservices project. If you not done this project, you are not able to understood the 5 microservices the project because these both are resume projects. Most important is two projects. If you add these points in a resume, definitely your resume will be shortlisted for the further rounds. This is the freshers and experience. Definitely, they both can do this project and apply it to our resume. Because in this video, I will cover everything. Okay? If you want to follow me in LinkedIn, this is my GitHub repository link. I will give you in the description in this GitHub repository link and my Telegram channel link. If you want the hands-on notes, join our Telegram channel group and ping me. I will share you the with hands-on notes with a step by step. Otherwise, you can join, you can connect me in my LinkedIn, and this is my portfolios, and you can take clone and you can do it like your portfolios also. This is my GitHub repositories, and this is my Medium blog. This entire project, I will write one blog and I will post it in my LinkedIn, or I will share it in my Telegram channel link or group also if you want, and can join our Telegram channel and can refer. This entire project with the step by step, I will write one hands-on note and I will post it in my Telegram channel. If you want, you can join our Telegram channel link. This is our YouTube channel. If you still you didn't subscribe, you can subscribe and click the bell icon. Whenever I uploaded the latest videos, you will get the notification link. Now, coming to our project. Kubernetes production level setup for a retail store e-commerce application with a 5 microservices. This project entirely I divided into 4 phases. First phase is project architecture and infrastructure setup. And second phase is Kubernetes and application understanding, entire applications. But because this application, I didn't written the code. This entire code, I taken the AWS containerization official code I taken and I push it to the my GitHub repository with I added the Terraform code and I added the Argo series and I added with resume building setup type. I added some codes and I added with automation to push it to the my GitHub repository. One is the total two branches I pushed. One is main branch, one is the GitHub branch. I will explain why I pushed in the two branches. I will explain upcoming coming follow steps. Okay. This is the entire application. You need to understand like what languages used, reviewing the Docker files and Helm charts, service to service communication pattern, everything you will understood. In 5 minutes, I will explain the detail. And third step, GitHub deployment and operations. In this entire 40-minute section, I will explain with GitHub actions. Like in this 11 microservices, we use the GitHub Actions with CI/CD. We use the Jenkins. But this project, we are using the GitHub Actions. We 5 images we build with parallelly and push it to the image and ECR and push and automatic update to the Helm charts. This is 40 minutes. And phase 4, what you learn, outcome, what you want to learn in the upcoming sections, everything I will explain. These are the 4 phases. First, I will explain the architecture. No, total 5 microservices I'm deploying. UI, order, checkout, cart, and catalog. In these 5 microservices, I'm using multiple databases. For the order, it will be stored in the Postgres SQL, and the checkout, it will be stored the Redis database, and cart, it will store the MongoDB, and the catalog it will store in a MySQL. These are total 5 microservices with the multiple databases. In UI, it's connected to the orders, checkouts, and catalog and cart services. Entirely, it will connect with multiple databases. The user is accessing the application. If any order is placed, all orders will be come to the Postgres databases. If user has been using our application, is order as placed in the checkout, it will be stored in the Redis, or its core will be stored in the MongoDB. Its catalog will be storing in MySQL. Okay, and this is the our application UI, the most popular secret application. This is the application. In application, I use the multiple languages. In the order in UI, I am using the Python language. In the catalog, I am using the Go language. In the checkout, I am using the JavaScript. So, JavaScript. And order, I am using the JavaScript, Java, and cart, I am using the Java with multiple databases. With Go language is MySQL, JavaScript is a Redis, and orders is a Postgres database, and cart is a MongoDB. This is the entire architecture. Now, this is the entire flow. Before come, I will explain something. In this video, I will cover Linux, Kubernetes, Docker, GitHub, GitHub Actions, Shell script, and Terraform. These many things I will cover. I will not cover GitLabs. I will cover in upcoming videos. These many things I am covering this video. And the project introduction is e-commerce application with the 5 microservices. I already explained this point. This is the multi-tier retail store application with multiple databases, multiple languages, and multiple services. We are using this application. And benefits of microservices and monolithic architecture. We need to understand monolithic and microservices application. See, monolithic, see, the entire application is running in one server. If one application or if one, see, this all microservices running in one server. If one service is failed, entire 4 services it will be failed. In monolith microservices, 5 microservices in 5 different servers. If one service is failed, remaining 4 services will be running as usually. This is the benefits of microservices versus monolithic architecture. And this entire application, we are using Amazon EKS Auto Mode in production level. I will explain now. EKS Auto Mode production level. This is the architecture, cluster architecture with EKS Auto Mode. What is Auto Mode? We are deploying in the only EKS cluster. In the cluster in EKS, there is a customer account and EKS account. This entire account managing the control planners like API service instance and etcd instance and storage and multiple EC2 instance and networking, everything EKS auto mode only, it will be managing. Everything automatically it will be creating. We are no need to create every infrastructure, everything. So automatically it will be created. If suppose uh, your application is running, I will explain it. See, it is auto mode EC2 managing the instance and other AWS services like load balancer and EBS volume and networking load balancer. If suppose your application will be load, hey, it's automatically create one more pod or one more instance to reduce the load and send the traffic to the one more instance. It's everything. It's a auto mode. It's not a manual process. Everything. It is the auto mode only. Everything is a cluster only will be taken. We go on the everything now. Now coming to the infrastructure deployment. First, we need to verify AWS CLI, Terraform, kubectl, and Helm charts installed or not in your local VS Code or terminal. Now, before that, I need to tell one thing. In this project, I am using entirely AWS Kiro. I'm using Kiro is similar to the VS Code or Cursor. But why I'm using the Kiro means this is the free. If you are stuck anywhere using the test prompt, you can automatically troubleshoot it everything. It's everything free. In the cursor, you need to buy the cursor flow access. In the VS Code, you need to buy the Copilot. But in in the Kiro, if you have AWS Community Builder ID, you have to free for the Amazon Q and Kiro browser. In upcoming videos, I will take one more section for the Amazon Q and this video Amazon Q. No, first you have to create one AWS Community Builder ID. I have already has Community Builder ID. I'm using that same Community Builder ID. If you have just sign in with your Community Builder ID or create some Community Builder ID and download Kiro, you open this link and download Kiro and extract and for accept all requests and install. And after that, it will open this kind of process. Sign with AWS Community Builder ID. After that, it will come like this process. This entirely free. Is entirely free. You can use the CLI also. It's everything. It is the free. Okay. Now open the terminal. For open the terminal, I will show you. I already installed the Kiro. In the Kiro also. Like this. Kiro. Now go to the extensions. Here you need to install Kubernetes. This is the Kubernetes. You have to install the Kubernetes and install the Terraform. Install this Terraform. These two have to install. Okay. And sometimes you have to keep it outside. Otherwise, you can use the this terminal also. Otherwise, you can use the local terminal also. I'm using the local terminal. Easy. My environment is download. I'm using that environment. Okay. First, you need to install AWS CLI. I given the commands in the main branch. See, if you're not installed, take these commands and install in our local. And after that, verify AWS version. The version it's done. After that, you need to verify Terraform is installed or not. Terraform, yeah, Terraform version I installed. Now I want to verify kubectl installed or not. Kubectl, it's a client version is installed. Kubernetes, it is installed. Now I want to verify Helm source is installed or not. The Helm also it installed. If you're in your laptop, it's not installed means go to this is the my GitHub repository link. I will share this GitHub repository link. The down in the Terraform, if your system is Linux or Mac, you can go this link. If your system is Windows, copy this link and install. And in kubectl also, if your system install is Mac, you can use this one. Or if your Windows also, you can use this one. Or Linux, you can use this one. And in Windows means you need to go through the extenders and install Kubernetes and verify kubectl. Uh, and after that, it's a not mandatory to install the Docker everything, but if you install means it's a benefit for you. And please install also and Helm charts you can install. Okay. Now everything is done. Now go to the this you have AWS account and go to the AWS IAM. We need to create one IAM. To the IAM. Deleting my actions not useful. Actually, confirm. Mm, attach access keys and confirm. Okay. I'm again refreshing one more time. Create IAM user. Name is Terraform CLI. CLI. Click next. Attach policies directly. Administration access I am selecting. Next. Create a user. Open this Terraform CLI. Go to the securities credentials. Here access key is there. Create access key and select command line in first CLI and confirm. Next. Create and download. And duplicate will be helpful next time. Okay. First copy access key. Here type AWS configure. Here paste AWS access key. It's my access key. Copy the secret access key. This now is entire application. I am deploying AWS account in US West 2 region. You also use this region because my entire Terraform code is written on US East 2 region only. I am using the same region and default output is my JSON I selected. You have so choose or build everything. Now I want to verify it's my AWS is connected or not in my CLI. That's why I'm typing AWS S3LS. Now some buckets is there. I'm just checking it's connected or not. See, it's connected. My last project, I created some Swiggy projects two. If you have want to go and watch that video, you can watch it. Okay. Now it's set up, it's done. Now I want to clone the repository. Okay. git clone, copy. Have already is there, but I will delete this one and I will create one more. Hmm, Deleted. Okay. Yeah, it's cloning. Now I want to check my Git branch. TD. Git. It's a main branch. No, total two branches is there. Um, Main branch I am using. Later on, I will use the GitOps branch. Why I am using the GitOps branch also, I will explain it. First, we will focus on the main branch. Okay, main branch. Now, kiro. Okay, not open. We will open directly. Kiro. Files. Open files. Go to downloads. Okay, microservices e-commerce and select. Yeah, done. Open the terminal. It's entirely free. You don't need to pay anything. Here there is a terminal is there. You can type it and multiple times you can deploy an agent, whatever you can, it's entirely free. Now I will check the Git branch. Entirely free by coding and everything. It's free. Now I am not using this one, that's why I'm closing. Okay, in main branch only I am using. Okay, the main branch, my entire code is Terraform. That's why I'm shifting to my Terraform CD Terraform. First, you know, entirely in one click, you can deploy the entire application. And with the two steps also you can deploy, with the three steps also you can deploy everything. But this project, I will explain. We root this main branch in the Terraform. I will explain the code. Terraform code, I will explain. Okay. First main branch. You know, first I'm creating the VPC with modules. You know, in my model VPC, my source is Terraform AWS modules in VPC. This is the my source. I'm taking this here. You can copy this one directly. Go to the browser. AWS VPC models. I'm taking source here. My every model I'm taking source on here. Slowly it's loading. Yeah, I'm taking here. This is my code. Do this slowly. Slowly it's little I modified. Okay. My version is 5.0 and my model name with CI/CD block, the public repositories and private repositories and availability zones and NAT gateway configure with the true and single NAT gateway and internet gateway and with DNS configures and managing default resources thing and applying with Kubernetes and this is the first. Now I'm going to the variables. The variables, my region is US East one and my cluster I will run Terraform init. We take Terraform init. Or yeah, meanwhile I will explain. No, my AWS cluster name is the retail store and environment is dev or can production level. I will just add in dev. Okay. My Kubernetes version is 1.33 and cluster Kubernetes cluster version is 1.133. CI/CD block is this one 10.0.0016 and Argo CD namespace is Argo CD and Argo CD is the versions and monitoring availabilities and everything. These are my securities. I allowed the HTTP and HTTP as traffic with my internet gateway and load balancers. It's port number 80 and port number 433 and allowing the load balancer health checks. It's Ingress Controller. I'm using 10254 and allowing the node ports range with the, all my services. Okay. And I will get the outputs like this in Terraform cluster name. It will come Terraform cluster name, everything. I will get it. Networking information, VPC name, CI/CD block, public subnets and private subnets, everything. I will get the informations and accessing the names and everything. Argo CDs and details, everything. I will come. So local abilities come. You know, this project I'm not explaining the Jenkins. That's why you can leave it everything. You know, my all projects like infrastructure I deployed using the Jenkins only. If you want to try it in Jenkins also, create one EC2 instance and install Jenkins and copy the password and paste it in the everything and set up everything Jenkins and create it a pipeline and copy this code and run pipeline. Everything it will build in single step everything. But I'm not explaining the Jenkins because in my YouTube channel, not many old members is there. Like everyone has same kind of projects. I'm explaining means they are getting a little bit bored. That's why I'm explaining with the new type of projects and new skills. Okay. Once that's why once it will be install Terraform in it. After that, we need to apply with the Terraform VPC. If you want to create VPC, normally means it will be take lot of time to connecting all internal resources. If you install VPC with the models with the Terraform, it will be hardly it will take 5 minutes. That's why I'm taking everything. Now, for the VPC setup, I given some details, quick setup, everything I given here. You want to go through this, you can go through. You want a hands-on notes with this YouTube channel means join our Telegram channel and I will give you. Okay. It will be take 30 to 3 minutes. Okay. Yeah, it's done. Now we need to apply Terraform model with VPC. Oh, yeah, Terraform apply target model for VPC because in the main file the main file VPC, my model VPC. I'm looking at the VPC. Yeah, VPC auto approve. Yeah, it will take less than 2 to 3 minutes only. Sorry. Running the background. Right. This YouTube channel, I not many videos is there. You can go on to for this YouTube channel, subscribe it, connect me in the LinkedIn and everything. If you want the hands-on or something, any doubts? Yeah. Verifying it's this part is done, and we will review the Terraform code. Everything it's done. Now we are deploying the VPC and EKS cluster we didn't deploy. First we deploying the EKS. We are here. Let's see. It's creating. It's creating the VPC, everything. It's total 24 resources is creating. Now, if you create it with the 24 resources manually, it will take minimum 5 minutes or more than 5 minutes. Now, if you're creating it automatically, it will be create everything and it will be attaching with every other resources also. Total 24 is see availability code, CI/CD, networking, and root tables and security groups with see, host names, DNS support, and enabling an IDs instance, IPv6, CI/CD block, IPv6 blocks with the networking, and main root tables, and owner IDs, and tag also. These many things it will be creating. It will be take 2 minutes. Entirely in the main branch only. This is no. You can clone my repository or you can fetch my repository. And I in this project I'm using the both branches. That's why I have created two branches. Why I'm using the two branches also I will explain when the time will came. No. It's going everything. Now, after that, once it will be done, means we can run the Kubernetes. Sorry, we can run the EKS auto mode. It will take 8 to 10 minutes auto mode. See, less than 2 minutes only it will be done, right? Now VPC everything it's done. Now we will deploy the Kubernetes. Okay. Now Terraform apply target module retail store. No, see retail app EKS. Okay. Retail app EKS auto approve. See, I'm running individually. First, I deploy the VPC, and after that, now I am deploying the cases. Now, you want to run the both commands at a time means you can go to the Terraforms, can run directly this step. Terraform apply target module retail app EKS and Terraform module VPC auto approve. Now, these entire modules with running with dependencies. one after one only it will be created everything. It will see entire infrastructure. It will be take minimum 30 minutes or 35 minutes. Its entire resources it will be creating, because the VPC it will be 2 to 3 minutes, and EKS cluster it will be take minimum 10 minutes. And after that we are deploying entire application with a one single step. It will deploy Argo CD, Helm charts, Kubernetes, everything, Prometheus and Grafana. It will take minimum 20 minutes. Total application it will take minimum 35 minutes. If you run this command, it will take 20 minutes. After that you run again. You need to run the Terraform apply. It will take minimum 20 minutes. Total it's 40 minutes. That's why only I'm running individually. Now once it will done means we will verify it. Once we will verify the VPC is created or not, go to the VPC. Your VPC, click your VPC. See, in your VPC, see, there's a total two VPCs is there. In one is the default, one is the retail store app. We are using this retail store app and subnets. Total three public and three private I created. See, this is the private, three private and three public I created, and root table. See, one is the default root table I created, one is the public root table, one is the private root table with three subnets. One is public subnet, three public subnet, three private subnets. Internet gateway. This is the internet gateway, and NAT gateway. I create a NAT gateway, and VPC connecting. I didn't connect it because of entirely one VPC, right? One VPC to one VPC, it will no communication. That's why VPC peer connection I didn't connected. And root services also I didn't connected. And go to the securities, networking, ACMC, network ACM is I created one default ACL only. And security groups I created. Total 4 security groups I created. Yeah, total 4 security. One is the EKS clusters, one is the root tables and everything. Four I created. DNS firewall. I didn't create a DNS firewall also. Everything it's done. Now we'll go on verified. Let's see. It's creating EKS cluster. It will take minimum 5 to no, it will take 10 minutes. I will explain the EKS cluster. See, this is the EKS cluster. Let's leave this one. Say module retail store app EKS source. I am taking this source and version this one. Base cluster configuration, cluster name. It's a local cluster variable name. It's a variable in the, here it's there. It will come here. Everything I will come later on this part. Okay. Cluster access configurations, public access true and private access true, and enabling cluster creation with admin permissions only true. And it's EKS cluster auto mode configuration. See, entirely it's auto mode. Auto mode networking configurations, taking previously I created VPC. I'm taking it's taking public IDs previously, and KMS configurations taking previously, and cluster logs it's taking everything this one. So load balancers, everything. It's a clear up destroying purpose. We can leave it this part. And variables, in the variables, the cluster name is retail store. Okay. Now I will verify retail store it's creating or not. EKS. See, EKS retail store. It's creating, still creating. Yeah, it's creating. Wait for 5 to 10 minutes. Okay, it's 3 minutes done. It's still 8 minutes in there. Okay, local. Yeah, project is data store. It's no taking this name and with tag names and everything here. Okay, wait for some time, and once it will be created, and we'll go on next steps. It's going on. It's creating. See, total 40 resources. It's taken tokens. Since you created the manually, how much? This is the cluster. This is the cluster endpoint. 1 minute. I'm checking my mic. Yeah, sorry guys. Actually, my mic is muted. That's why suddenly my desktop is stopped. Okay, let's come to the point. This is the cluster endpoint, cluster name, and cluster fixes, and this the everything the cluster region, security group, and in configuration everything it's given. Now, if you see this, the cluster is auto mode. That's why cluster is created, but nodes is not created because of the application is not running. Whenever the application is running, at that time only the based on the topic only the nodes will be created. Minimum is 2, maximum based on the load, desired capacity is 2. See, cluster auto mode, it's enabled. See, pods, no. Replicas, not there. See, deployment, there. And come to the nodes, clusters, nodes, no nodes is there. Put the computers, networking, see, VPC, three public subnets and private subnets, security groups, and add-on. See, accessing. See, it's taking Terraform CLI. First, I created the Terraform CLI. It will be taking on Terraform CLI. It's added its resources, everything. It's created. Now go to the EC2. You will get the better clarity. The nodes is installed or not. Go to the instance. 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 See, this is the old instance. Is the stop. Okay. There's no instance is running because whenever the application is running, at that time only it will be created. Otherwise, it will be not created. Okay. Now the main step. I'll show you the documentation. Okay. Deployed core infrastructure VPC with providing the network and EKS cluster with the step 3 start. Now configuration kubectl access to the newly created clusters. Now, now we need to configure the if we are newly created cluster, I need to configure the EKS clusters. I need to update the kubectl configurations. That's why go to the kiro. This is my kiro browser. Okay, copy this one. See the output only. Copy this one. AWS EKS update kube config and region US East 1 name is kubectl. Just update it. No, this command will be downloading the EKS cluster authentication information right into the dot kuba config and allowing the kubectl to communication to the cluster. This command will be do these steps. Like it will be communication with the kubectl in the cluster. Now I will run kubectl. get pods, nodes. No nodes is there. Nodes is not there. And kubectl get pods. Kubectl get pods. Here also no resource will be because the application is not running. Now, with a single click, we will deploy the entire application to taking the this EKS cluster and VPC setup. Okay. Now I will run the Terraform apply. After that, we need to do everything. Okay. I will explain the later on the code. Terraform apply auto approve this command. Wait, I will explain the architecture after the get the clarity. See, through the Terraform, first we deploy the VPC, and after that we deploy the EKS Automode cluster. These two it's done. Now we are deploying with using that Automode and VPC retail store application with the pods deployment services, Ingress Controller, ArgoCD, Helm charts, and Ingress. This many things we are deploying everything now. Using the Helm chart, we are accessing the entire application now. Okay. See, See, it will be install like first, it will be install the Ingress controller. Yeah, first it will install the Ingress controller. Ingress controller is providing the external access to your microservices and creating the AWS load balancer with networking load balancers. It's the first, and it will be create certificate manager also in the code. See, it will create a certificate manager with TLS certificate. Automatic HTTPS request will go like it will redirect HTTP with a HTTPS. See, everything is done. Now NGINX Ingress Controller, it's providing external access to your all microservices with creating the load balancers. This it will be going. See, so, some of the services it will be modifying, and some of services it will be because the application now the ingress controller EKS specifics will modifying some of the services like total 17 services it will be changing and it will updating the 24 27 because the Argo CD it will be installing load balance, it will be installing namespaces. The auto mode it will be creating the nodes, pods, and everything. That's why it is modifying the all. See, it's modifying the KMS. It says like it's modifying the VPCs and everything. It's modifying the public service, private service, modifying it. Modifying. Finally, it will be creating the Helm charts. No, first it's creating the Argo CD. No, it's creating the Argo CD. It's creating the Argo CD with the GitOps container deployment with the sync of Kubernetes manifest files. It will sync with this manifest files. This manifest files. In this manifest files, it will install Argo CD and sync with all manifest files. This all manifest files it will be synced. See, this is a name, retail store code, and Argo CD is the namespace, and project name is retail store. This is my GitHub repository. You need to replace your GitHub repository when you clone my repository. Otherwise, do form, if you do the form, if you do the fork, there's no problem. If your form is, you can directly my GitHub repository will be take it, no issues. No, it's a main repository because in the main repository, my all public repositories links is there. See, it will be taking in the my main repository. In the main repository branch is main in the SRC code and chart. SRC code services and chart services. In the chart service value.aml file is there. In the aml file there is a image is there. This image is public repository. No, in the main branch, entirely I taken the public repository. I already informed the starting of the video. I taken the code from the official AWS containerization. That's why I taken all public repositories to in the main branch. No, later on, entire application is deployed. After that, I change my branch to the GitHub and I will deploy the latest image and I will push it to the my Helm charts. That's why this main branch entirely in the public images. Now you got the clarity why I am the maintaining the two branches. In the main branch is the public repositories and my GitOps branch is the production level private repositories. Later on, I will do with the phase three. That GitOps branch is the phase three. This is the main branch in the phase one. Okay. No, it will go and take the volumes and the service and namespaces. Its namespace it will create retail stores and everything. It will be done. It will be synced with the this YAML files and deploy the latest image and it will give the UI from you know, this UI also it will taking everything it will be built. With this UI will connecting all services and giving the this thing. In this thing, creating the ingress controllers, creating the ingress controllers and certificate manager and Helm charts and Argo CDs and with the pods, with the deployments, services, ingress controllers, everything it's done. We can using the Argo CD ingress controller. It will create one microservices UI networking load balancer. Through the networking load balancers, we are accessing the our application and it will create the Prometheus, Grafana and alert manager to monitor entire our public repositories application. Now, later on also, we can change the repository, we can push to the private repository also, we can monitor entire application. See, it's installing the Prometheus, certificate manager, Grafana, and certificate managers, everything it will be installing. It's see, with a single click. See, when I'm explaining with the 5 to 10 minutes only, it's created everything. See, I think it's everything it's to get created. Now you need to access the application. Okay. It's created, English control it's created, certificate manager it's created, Argo CD it's created, Kubernetes namespaces is created, and pods, everything it's created. Now you need to check kubectl get nodes, kubectl get namespaces. See, Argo CD it's created, certificate manager it's created, ingress control it's created, kubectl it's created, and kubectl public it's created, Prometheus it's created, and application it's created, right? Now I'll check the pods, how many pods it's created. Or this is the all Argo CD pods, and this is the certificate manager pods, and this is the ingress controller of our application pod, and this is the my monitoring pods like Prometheus pods and Prometheus and Grafana and phased alert manager pods, and this is the retail stores with UI orders, catalog, and checkout and code services, pods, everything. Every pod is one pod. No, in the I explained like benefits of microservices and monolithic architecture. If one pod it fail, remaining four pods it will be work. If two pods fail, means remaining three pods it will be work. This is the entire architecture deployment. This is the single step of deployment. Everything it's deployed. Now we need to monitor. Now we need to verify the application. Okay. Before that, how many steps it's completed, I will check it. Sorry. Okay. Deploy infrastructure VPC with providing the networking with the EKS cluster is done. Configure the kubectl access with the newly created EKS cluster and deploy the platform services like Ingress controller and certificate manager, Argo CD, and here Prometheus and Grafana and alert manager also we created and verify all it's running or not. Now we need to check everything it's running or not. Okay. Terraform output. Right? Actually take, yeah, skip. Okay, now we need to monitor the, we need to access the application, right? We need to store application. This is the command. Copy this one, paste it here. Yeah, this is the Ingress Controller application. You can access our application. See, this is the our application. Uh, With a single click, we deployed entire application and we are monitoring the application also. See, explore. Now I want to order something. See, now I want to order. See, all its services, it's working or not. We need to check it. Now it's a checkout services working. Order services working. Payment services working. And catalog services it's working. I'm confirming. Purchase order. It's order. It is the order number. It will be stored on the MySQL. And this order placed. Everything is there. Now I'm going back. This is our application. It's entirely, it is working. Now we need to log in our Argo CD. You can take the links directly here. Otherwise, you can take directly here. Go to load balancers. See, here the application is running in one instance because of there's a no load. That's why it is like one instance. If my application hit 1,000 requests, it will create two instances or it will create three instances. Now there's a no load. I'm not given my application to everyone. That's why it's created only it's created on one instance only. Later on it will create two, or later on it will create three also. uh, Based on my load. Okay. Based on the load only, it will create the pods. Based on load only, it will create the clusters. Based on load only, everything it will be based on the traffic only. It will be created. Now open a load balancer. Total five load balancers is created. One is the application and Prometheus, Alert Manager, Grafana, and Argo CD. If you want to take this Argo CD directly, you can take it here. Otherwise, you can follow here. I will take here command line. This is the Argo CD. To or load balancers to access. Yeah. Mhm. Link and we will access. Yeah, sorry, it's I didn't copy it properly. This link I copied a wrong link. Yeah, echo link I want to copy it. Yeah, now it will get mine. I copied the wrong link. Yeah, in the Argo CD. Okay. Okay. Username is admin and password I need to copy here. Oh, password output I didn't go in. Okay, no problem. See, if you go for the main branch, go down a little bit, go down, down. See, in the Argo CD automatic deployment, here in the step number 10, port forwarding to ArgoCD UI with logins. Copy this one. I didn't mention in the code, that's why it's not showing the output. No problem, you can take directly here, paste it here, you will get the output. Password. This is the password. Paste it here. See, with the single command, Terraform auto approve apply with a single command. See, it's retail store code, retail store catalog, retail store checkout, and retail store order, and retail store UI. Everything with a single click, it's deployed. See, in the main, this is the entire code, is the main. In the main means it's the entirely in a public repositories. In the main, everything is the main. This is the entire UI. Okay. Now, okay. I verified everything. Verify all components are running. It's done. Now Argo CD setup and accessing it's 50 minutes. It will take 30 minutes. Like it's done almost 30 minutes. It's done. Accessing the Argo CD with the load balancer. It's done. Accessing the Argo CD with administration security. It's done. Set Setup port forwarding to accessing the UI. It's done. And reviewing the all principles of benefits of this one. This one is there. Okay, we will review once. Okay. See, these are the cloud services. In the cloud services, same like here. Pods deployment service and ingress. Same here also. Pods deployment ingress, everything is there. Services, pods, service accounts, and everything is there. And port forwarding also we will see. STC, ingress controller, and see. This is the HTTP port is 80, port forwarding TCP with HTTP. This one. This is everything. And this is the catalog and see ingress control deployment files and ingress controller with the secrets, that database secrets, the DB secrets. This is the DB secrets. This is the database secrets, is the user ID and password. You will get it if you want, means you can directly go to you will get it. This is the part while explaining. This is the database details and everything. If you want database directly, you can copy this one. You can launch the server and you can access the data is there or not. You want this the details and checkout services. In the checkout services, hot services, port forwarding is 80, HTTP, TS, and everything is done. And so same is order. If the database is a Redis, our order is a Redis. And see, this is the passwords and an ID password, and you can copy directly this link. You will get the IDs and passwords and everything. This is the name service, everything. See, this is the details of the deployment, and this is the port forwarding with the port number 80. We are accessing the load balance with the port number 80. That's why it's everything. It's the port number 80, port number 80. And this is the UI. There's in UI, everything with the cluster, English controllers, everything. These are in UI. It's connecting the all uh, services to the UI and port forwarding with the Prometheus. Prometheus is a 8080. And it's at in UI only. Prometheus and UI, everything is there. The Java, not everything details. It's connected to the UI, and in the UI we are accessing everything. And it will store the port forwarding with the port number with 80. See the port forwarding with the 80 with the HTTP. It's done. Yeah, it's done. Now monitoring and observability practice. We already deployed Prometheus and Grafana and PagerDuty. Now we can access. You want to access the load balancers, and you can go So the load balancers you can access here, but I don't want to access to here. I want to access in the kiro CLI, the easiest method. Okay, Terraform output. Okay, check it. Yeah, here grafana is step 5. Want to access here. Okay, yeah, I'm copying here. I'm opening one more. Accessing. Yeah, I want to check now user ID passwords. User ID admin and admin 123. Admin 3. Yeah, yeah, it's login. Now I want to access Prometheus also. And this is the Prometheus. Okay, login. Now I want to access Prometheus also. Prometheus, I didn't allow the port number 9090. That's why I'm allowing the port number 9090. I'll check it without port numbers I allowed or not. I didn't allow the port number. That's why I'm accessing the port number 9090. Okay, it's a Prometheus. Now I want to access the alert manager. Alert manager is the alert manager. Copy properly. Hmm, yeah. This is the alert manager. Okay, now I will explain the Grafana. After that, I will come to the promptness. Okay, in Grafana, you can go for the dashboards. See, already node exporter fetch that all logs and everything here. Now you want to access the here. Okay, and now you networking and everything. Okay, node exporter nodes. See, these are my CPUs and load memory uses. This is and disk space, everything. See, this is networkings, everything. And I want to explore for the pods. See, this is the my pod, everything. And I want to explore the nodes, Kubernetes nodes. This is the Kubernetes nodes. I have only two instances. Now, see, before it's only one instance is there. Before only one instance. I go and check it here, EC2. See, before one EC2 instance, because of my application, it's running on one server. Because at that time, I am only ArgoCD and EC2 ArgoCD and application only it's running. But now I am accessing the load balancer. Sorry, now I am accessing the Grafana, Prometheus. and alert manager. That's why it's created one more server. See, it's at the starting of the time, it's created only one server. Now it's one more server. It's increased because of I'm accessing the Grafana, Prometheus, and PagerDuties. That's why the load will be given to the one more server. The two servers is there. See, these the two servers and everything. See, retail store UI, this access and retail stores and everything, memories uses and everything is there. Now, namespaces. I want to check how many namespaces is there. See, total namespaces is Argo CD server, Argo CD repo, Argo CD Redis, Argo CD notification, Argo CD this many load balance namespaces is there, memories uses and the high CPUs and CPUs everything. This is the Argo CD. And I'm checking the certificate manager. This is my certificate manager load. And I want to check the Ingress Controller NGINX. And I want to check the retail store. This is my retail store deployment. See, this is the UI because of it's running in one pod. One pod. This is everything. It's one pod. These are the orders. One pod, checkout, one pod, catalog, one pod, or everything. It's one pod. That's why I'm accessing only one. I'm only accessing one request only. That's why it's coming. It's very less CPU request. 0.13 requests only. It's came. If I hit like 3-4 times, it will be increased 0.13 to 0.14 like the seats. It will be changing then each this the thing. These are everything details like bandwidth and everything. 0.3 everything here. Namespaces and everything. It's collecting the Prometheus. Okay. Now go to the dashboards. And I want to check the clusters. I have running only one cluster. I want to check the one cluster. That cluster is CPUs, which is 4.0, and CPUs requests and memories requests. Everything is there. See, this is only one cluster is running. That clusters accessing the Prometheus. See, that cluster's namespaces, network uses, and everything is there. See, bandwidth, average bandwidth, and rate of packages and everything is there. Mm, and I want to check my core DNS. These are my core DNS is the empty because of DNA is but there's no DNS core DNS. And I want to alert manager overview. This is my alert managers overview. See, these are my alert managers. Alerts on alert. See, this is the alerts. I can run the query like this and silence and status. The status and settings and helms with the alert managers. See, there is no alerts is there. That's why the everything is it is the normal here. And my API servers first I see my APIs everything. Let's see. Read and release 90% because APIs will be communicating with one server to one server, like one microservice to one microservice. That's why the load will be very high to accessing everything. That's why the communications is high. If my request will be high, it's automatically there is a one more instance will be created here. Previously it's one instance, now it is increasing the two instance. If my load is come very high, it's there is a one more instance also. It will be everything. And Prometheus overview. These my port numbers. kubectl is 1012 and every API score port so everything here and it will be synced and targets and everything. It's the storage and everything here. It's an overview of the Prometheus. I can directly use the my Prometheus. It's the graph and alerts. See, my health check is everything. It's normal, but my health check, see, its memory, it's over limited. Like, see, that's why only that one more server is increased. One more server is increased, but the here why is overloading? It will be take time for 5 to 6 minutes to 2 to 3 minutes to shuffle the load to the one more server. That's why it will be solved automatically the issues. In my YouTube channel, I already has taken the lectures in the SRC site reliability engineer. You can go and watch. There's only two videos is there. One is the metrics, one is the over. You can watch the metrics. You will get the better clarity. See, this is the section two SRC metric. You can watch this video. You will get the better clarity about the Prometheus, why it is coming this kind of alerts. Again, automatically why it is the solving the issues. You know, this kind of issues it will be automatically resolved. You can watch this video. It's only just 1 hour 22 minutes only. You will get better clarity. I will explain in detail. I will explain. You will get more clarity. These metrics in the Prometheus. In this server, I used in the pager duty. I explain like pleasure duty to the Prometheus to the Grafana. How I explain in detail. I explain. If you watch this 1 hour 22 minutes video, you will get the clarity about this uh, kind of errors. After some time it will automatically resolve these issues. Why how it will be resolved automatically means you can watch this video, you will get the better clarity. This one, watch this video, okay? This is the Grafana. It's done health checks, everything. It's good. Node exporters and everything is there, and you can create the dashboards also. Create the dashboard and add want with this, and you can query the data also here, or you want to import it also, you can do it. As we can import, you can load it and import also, or you can upload the files or import like in the see medium block. In the medium block, my profile, I written one block regarding the Prometheus and Grafana page duty regarding that same video only. Yeah, this one. You can read this blog. Otherwise, you just, can watch that video study video. You can understood. This blog will be taking time to loading. Yeah, it's done. This is the blog. You can just read this blog. Yeah, this loads is that I want to access the nodes. Kubernetes nodes means this is the 6417. 6417 load from this imported. See, this is the my CPU's load. These are my nodes. Totally, it's see in the my node only deployment, like it's running in one pod. UI orders, checkouts, core services, and Prometheus and everything. It's running. It's the pods and everything deployments. This is deployments, and total two nodes is running, and total 25 pods is running, and one pod is pending. Okay, you can go and check it. It's here. Kubectl will get pods. Otherwise, no problem. You can check me directly. Okay, one pod is pending and zero pods it's failed and everything is running. See, that 30 containers is running and everything you get it. He health checks and everything. It's everything. It's normal. The port is normal. CPU load is normal. Everything. That's why see deployments is this kind of method. You can save it and go to the dashboard. You can save the dashboard. The custom dashboards. Like you can create the custom dashboards and everything like this. This is the overview of Prometheus, Grafana, and page entity. I hope you got the clarity. Now we can go to the page 2. I hope you got the clarity. But okay. Okay. Prometheus and Grafana, this one is done. And production level troubleshooting and metrics. It's done. Entire phase 1 it's completed. Now come let us go to the phase 2. It's almost 1.5 hours. It's taken the only phase 1 only. Now phase 2 it's completed very fastly. Okay, see, as a DevOps engineer, creating the Kubernetes clusters, deploying through the Argo CD, it's completed, giving the access to the users. That is a not a DevOps engineer's work. DevOps engineer's work is a DevOps plus Dev plus operations. Whatever the developers has written the code, you have to understood the code and you have to write the Docker files and to review the code entirely, and you have to build the images and to deploy the applications. Now, each microservices you have to understood. See, in the SRC, in the code services, in the architecture also, you and take the codes, catalog services. First, we will take the code services. In this code services, in SRC, the main file is entirely written the Java code. It's, you have to understood which language has written the which services. You have to understood the each microservices and everything. You have to understood the code. And second, after code, you have to go to the catalog and you have to check each which language has it is written and everything you have to written. So if you go for the code, if you review the Docker image, see in the Docker image it is taking as a public ECR list. It will build stage from it will take in the Amazon Linux 2023. That's public image it's taking. It is the run DNF Maven because it is a Jenkins code. That's why it is the Jenkins, and it will run the it will artifactory. It will be check it and volume temp and working directory will be changed and copy the all .mvv files and copy the form.xml. In the form.xml only entire code is there. It will be install the packages and everything. Port will be 1000 and it will be run and it will be executed the app.jar file. It will be deploy the application. This is the code services and catalog services. If you go for the Docker image, see in the Docker image, it will be taking same public images Amazon DNX in 2023 and run it's taking gate and it will taking the which language Go language. You have to understood the code and you have to write the Docker code and which environment which .env file has written and everything you have to understood and you have to write the Docker image, and after that you have to build the Docker image. You will get the better clarity wherever the issues is there. You can go there and you can fix it the issues. That's why say run go build, it will be entirely build the packages and everything. It will create the repository and everything app.main. It will run and it will be uh, build the image and it will be execute the application and check out. If you go again, it is the entirely JavaScript. We written the entirely JavaScript. That's why we taken the Node.js application It will take the entirely it one checkout. So the checkout service, we taken the JavaScript. In the JavaScript, see that's we taken the Node.js and explore the port numbers and a home directory in the app that creating the home and user ID, and we can take it, and finally we are building that main.js file. It will be build the image and we can execute the application. This you have to understood like this. And orders, again we have written this code on the Java. The Java, if you take the manual and everything, it will be build the form.xml, and it will drop app.js file. It will be run and it will be executed. And in the UI, the core services and catalog services and checkout services and order services, everything will be to connecting to the UI, and will be building the image like it's a job. It's entirely in Java. See, in UI, we written in Java language, and the UI, here, the UI, everything it's running like a dot src. See, in the src, we are taking the everything and building the images. Like here, we are taking the ports and everything, exploring the application and building the app.js file. Okay, reviewing the Docker. And now we need to analyzing each microservices business purpose to and technology stacks it's done, reviewing the Docker stacks it's done, and now Helm charts templates and value and each. Okay, in the SRC, go to the code services. In the charts, here value.ml file. See, here I taken the public repositories. In the I previously I told in the main branch entirely public repositories. I'm taking the public repositories, and which database I am using? MongoDB. I'm taking the MongoDB details, and port number is 8000, type is cluster ID. I'm enabling false and everything details. The service request, the image, MongoDB's I taken the public repositories and everything using the port number. This is the jobs. And go to the core services and check out. See, here I taken the public repository catalog, and it- I taken the public ECR AWS Docker library. I taken the MySQL image. I not created the database separately from here. I taken the public repository. The public repository, I am giving the securities, and I'm giving the tags and cluster ICs with the port number. See, using the 3306 port number, and I'm writing the read access and readable write access and everything and storage, and see I given that the 10 GB everything I given minimum availability 2 and maximum unavailability it's 1 I have taken. Same like catalog, if you go there, this is the passwords, databases passwords and everything. If you go pass and value, right? Again, I taken the public repositories. Later on, I will be changed once everything. It's I build the ECR images. After that, I will be changing. I'm not changing here. I'm changing in the GitHub branches only. In the GitHub branches, I am connecting to here. See, I'm taking the Redis database. The if not present, it's tag number 6 dot chart cluster IP and port number is 6379. The port ID. And orders charts. Then taken again public repositories, and here the database is PostgreSQL. I same image I taken like public.ecr.aws Docker and library but this tag number is 13. Postgres SQL database port number is 5432 and replicas and I 10 GB I given readable and writable access and everything I given. Port number is 5679 I given. Okay. In the UI, you don't have any databases because in UI, it's connecting to the front end to the back end. See, so all services to connecting to the UI. That's why in UI, we don't have any databases. Okay. This understood. This is the very important understanding is service to service communication pattern. Like we have five services in UI, catalog, core services in orders. Like all services is connecting to the UI. How it is communicating to service. This is the very important. See, if you go the apps, in the apps, well, u.ml file here, caught and checkout catalog and checkout services, order services in UI services. See, all individual services, it's connecting to the UI in the app endpoints. No, checkout endpoint, catalog endpoint, cart endpoint, checkout endpoint, orders endpoints, all endpoints, it's connecting to the app. Its app is connecting to the UI. It's automatically. If you hit the UI, automatically it will hit the app services. App services hit to the this catalog and cart services and checkout services in order services. It will be get backed. And in the databases also, see in the cloud services, MongoDB and MySQL, Redis, and Postgres SQLs, everything, it will be connecting to the UI and see all public repositories connecting to the UI. CQ. Is that hand? Okay. Now you got the clarity about the how service to service is communicating. Okay. And containerization deployment understanding. It's done and reviewing the Helm charts. It is done. Analyzing the Argo CD application with the sync to the output and understanding how services as exploring the ports. I already explained this part, which service and which port. I'll show you one more time. If you go here and go to the SVC, in the SVC at which port is servicing. See, port number 80 the Helm charts and core services and everything here is there. It's giving the everything here. In UDI number and everything, cluster IPs, and which clusters accessing everything here, details is there. Same like everything like that. In catalog also, same like if you want the database secrets, if you want to go to the catalog, you will be able to access the here the database details and everything. This is the way. Okay. Okay, this app phase 2 also it's completed and phase 1 you completed and phase 2 it's completed. In the phase 1 and phase 2 you have stuck anywhere or if you want the hands-on note, join our Telegram group and ping me the message and I will reply you as per as possible and I will solve your issues. And now let us go to the phase GitHub actions. GitHub deployment and operations. It will be take 40 minutes time, but I will explain very quickly. I will explain the architecture now. And in a phase two, I will give the quick review, quick summary about that. You will get the better clarity if you have stuck anywhere. Also, I will give the quick clarity about that phase two. Okay. In the phase two. Okay, in the phase two, first we will take the catalog service, core services. We go to the UI. Okay, okay. In the catalog service, core services. These core services, we written the Java application plus MongoDB. and it stands for we can shop temp we can shopping we are shopping the using our application we can shop, and if user has been sent to the cart, that it will be stored in the MongoDB. And checkout services we written the Node.js and JavaScript. With two language we have used it in the language. One is the Node.js language we used, and some JavaScript also we use Node.js and JavaScript, and plus Redis database, managing the checkout services, and temporarily it will be stored on the catalog checkout storage in the Redis database. In order services, we written the Java code, and with MySQL, we will processing managing the customer's order. It will be stored on the MySQL. In UI, we written on the entire Java language, front-end web application, service HTML UI, and backend API calls with no indirect perpetration of layers, app services, all things. It will be connecting to the app services. In the app services, it will be connecting to the UI, everything to access in the application here. Now you will get the better now you got the clarity about the phase two. Now phase one and phase two it's completed. If you have still have doubts, can ping me in the chat box. I will be reply and I will be explain it. In the phase three, GitHub deployment and operations, it will be take 40 minutes, and I will explain the architecture. Okay, using the Terraform, VPC done, EKS cluster done, application is done. We are using the Argo CD. We are deploying the applications. Now in the phase three, GitHub CI/CD pipelines. In 11 microservices application, we deployed as a Jenkins. Now this is the GitHub Actions. Developers has written the code. This is the developers has written the code. I taken the code and I written some of the my purpose of the code, and I pushed it in the main branch, the entirely public repositories of the code to the production level. Production level and yeah, in the production level, it is the GitHub. In the GitHub, it will be test the unit testing and factory build, and it will build the image using to the GitHub Actions. It will build the Docker image and it will push to the Amazon ECR. It will be latest image. It will update to the here Helm charts like here latest image. It will be updated to the each microservices in the code services value.m. Here latest image it will be update here. If the image will be updated automatically, it will be trigger the GitHub Actions. It will give the latest image. Okay, this is the way. Okay, now let us start the process. Okay. Mm, okay, now in the GitHub Actions, I'm using the same IAM user only. The same IAM user, same it's this one. In the same IAM user only, I am using the GitHub Actions. That's why in this application, using the GitHub Actions, that's why we need to configure the AWS secret key and access key in our GitHub Actions. That's why I'm going to the GitHub Actions and go to the settings. In the settings, you can go to the secret and variables. Here, go to the actions. In the actions, see, I already configured. Okay, see in the AWS user key ID, you can just edit here. Otherwise, okay, here you need to give secret key. Secret key, copy secret key. Okay, update here. We get the mail ID. We have to enter the OTP. I'm checking my mail ID. Uh, okay. Okay. 2 minutes. I'm checking my mail ID. Yeah, it's kept. Okay. 68787538647. It's updated. It's updated. Now, account ID, go to this is the account ID. Copy the account ID, paste it here, update. And region, we are using the AWS account in US East West 2. We are using the West 2 region. We are using the AWS West region. That's why I'm just updating the West region. US West 2 region. West 2 region and AWS secret access key. I will get here. Key update. Just do one thing. Create a new repository, create three and name and update. Now, if you are confusing, that's why I mentioned here also. In my GitHub, the .md file also I mentioned you have to go and put it. Otherwise, you can just simple. If you're watching my video also, you can do like same names only. You have to copy it because of my code also it's same thing. Okay. Okay. Now I will tell you why I am using the two branches. Because first branch is I am using the public images because I don't want to change my public images. Because if we are using my code in some members or some other, you all are doing the practice with my YouTube channel. That's why you can for you. That's why for your convenient. That's why I'm not changing the public images. I mean my main branch. That's why I am changing the public images in the my GitHub branch because it's the best practice. This is the I go into the GitHub branches. I am not deleting everything. I'm just only one command to shift to my branch to the main branch to the GitHub branch. I'm doing the my command line. See, I given here all informations. Now I explain here. Okay. Now I'll explain the branching strategy. Explain the branching strategy. Yeah. See, developers code changes, target branch, no main branch. It is a sample deployment. It is the manual deployment with the public ECR repositories with the Helm charts. With target branch, it's the production level GitHub branches in GitHub actions with the code push, updating to Helm charts or auto sync Argo CD, and it will push to the private ECR images. It's a valid application deployment. That's why it's a production level. That's why I'm leaving this branch at the same time. I'm just to connecting this branch to the my application. Okay. See, it is the main is there. Target is the main is there. Main is there. Here, everything is the main is there. No, I'm just replacing to the main branch to the my GitHub branches. Okay. Just I will. Okay. Now I will check my branch. Git branch. Okay. If anything, it, it pull. And now my branch is GitHub. Now I want to change my branch to the GitHub main branch to GitOps branch. That's why Git GitOps. Yeah, I entered my code. See, because see in the main my GitHub repositories, here my GitOps only I have written the code in dot GitHub in workflow, but in my main branch, but I didn't written the code because I it's a fixed images. That's why I don't want to change that images. That's why I created one more branch. One more branch. In the one more branch, the workflow here I give. Okay, now I will explain the code. Name is deployment on push branch GitHub. Whatever the changes in the GitHub, in the GitHub branch, the path is SRC. In this SRC, any changes in any file, in any code, catalog, orders, and UI, if any change, like any workflow, it's detached, anything, it's automatically it will be run the GitHub Actions. Environment is AWS region is US West 2 region. It will be take the credentials to there and job detach changes. Name is detach changes services on Ubuntu server, Ubuntu latest. Every GitHub action, like there's a default Ubuntu service and Linux service, and everything is there. I'm taking the defaults one, the outputs and everything. Any changes, actions, checkouts, or fetch deep with to everything like it means like in the SRC, UI, catalog, code, checkout, and orders. If any changes, it automatically run this pipeline. It will be telling. And see, this is the metrics. Metrics means like, if you observed in my 11 microservices project, I deployed in one by one microservices. But here, 11 microservices at a time, parallelly, it will build the Docker images. Because here I used service to build with generating the metrics, with step by step, like metrics dot services, like all services at a time only it will build. If one services, it will be changed, it will be one service. If five services, it will be changed. It means five services at a time, it will be detached and it will be build the images. No? This is the way. Taking the AWS credentials, secret key and access key and everything and region, it will be take and log in the AWS ECR and it will create the images as a service, a retail store. Service means, yes, service I mentioned here, services in the services, UI, catalog, code, and checkout and orders. Based on that, it will create the names, it will create the repositories and build with the tag. Tag means here based on the comment ID only, the tag with comment ID only, it will be tag and it will be create the repositories. And in the repositories, in that we have taken the account ID name, account ID, and it will be build the Docker images and build and push to the Amazon ECR repositories and update to the Helm charts values with the metrics dot services. At a time only, it will be update to the Amazon ECR, or if one image, it will be changed only to update in one image. Based on that, it will be take in the GitHub actions dot with the env dot ECR repositories and volume dot src and service core dot volume dot c. In the src, the SRC, if checkout services means in checkout services, code services means code services, and catalog services means catalog, order services means order, UI services, you take the code services, in the code services, in the chart services, value.ml file services, here it will be replace the image. Okay, will replace the image here and it will be tagged and it will be filed and everything. It will be validating the file executions and it will build the image and it will be pushed image and it will be updated in the GitHub, in the update in the GitHubs. See, it will be committing the Helm chart changes with metrics and it will be pushing. And this is the summary of deployment and name of the services and everything. It will be get the output. This is the deployment.ml strategies. Automatic with the AWS automatic with AWS using the GitHub secrets, build the images, push the manifest file with the GitHub repositories, sync with the Argo CD, everything. Now, uh, I want to build the images. Okay, I want to build the images. Okay, Mm, I want to build some images. Mm, Then I okay. Now I will do some changes because in the GitHub Actions, if any detect the changes only, it will be build the images. Now, if I go uh, go to the AWS, will type ECR repositories, ECR repositories, Amazon Elastic Container Services. Okay, here public private repositories, private repositories. There's a no images here. That's why I want to build some images. If I do some changes here, it's automatically detect the changes and it will be pushed. It will automatically trigger the GitHub actions. That's why I will do some normal changes in my code. Mm, Go to the okay in the code services in the README file mm, and demo changes and catalog and README. Then and code checkout services readme file. It's done. And order services readme file. It's done. And UI readme file. I did some changes. Okay, again I will do some more changes here. GitHub. Um, Almost I did changes. Now, okay. Mm, Git, git status. Yeah, I did some changes. Okay. And now I will add git, mm, git, yeah, now git, git commit, modified, add new futures, futures to readme the file. Yeah, now git push. Mm, updated. Everything is done. Now go to actions. The actions, see, add new features to the readme file. See, UI, catalog, cart, checkout, and order. It's a parallelly it's building. See, it's metrics with a parallelly metrics deployment. This is a metrics deployment. It's a parallel everything. It is the deploying. This is the tag name C4D1 ABB. It's a parallelly it will build and parallelly it will be pushed to the ECR. Okay, it will be take minimum uh, less than 5 minutes only. 5 minutes only. If it is built automatically, it will be created images in AWS ECR. Check it, and once we'll refresh, it's automatically 5 repositories. It is create. Yes, see, 5 repositories. It's created. If you open the codes UI services, no images is there because of images. It's not built. It is building now. See, if you do these steps in manually, it will be take minimum 15 to 25 minutes. It will be take for one image, only one image. To build the Docker image, it will be take minimum 5 to 10 minutes, and it will push to the image in 2 minutes and update the images. It will be 2 minutes. The deposit it will give minimum. It will be take 15 minutes to 20 minutes for image. For 5 images means it will be take minimum 1 hour or 1.5 1 hour or 1 hour or 1 hour 20 minutes it will be take. But yes, see, it will just 1 minute 33 seconds and 1 minute 45 seconds only it's taken. Now if you go for see, it's 1 2 minutes only it's taken. It's see, now if you go for the core services, see, latest C4B1 it's latest image it's built. See, it's 2 minutes 14 seconds. It's every image it will be taking less than 5 minutes only. It's a parallelly it is building and it will be pushed to the it will be here. So if it is completed, you can go and check the Helm charts. Latest image it's built or not, you will check it. See, it's done and it will be started the deployment summary. See, deployment summary. See, comment this one and branch is GitHub and triggered by Ashwant Reddy Armulla and changes UI, catalog, cart, and checkout and order deployment is successfully and actions commit, build and push the Docker image to the ECR, update Helm charts volume, and commit changes to repositories, and Argo CD will be sync automatically. Now, if you go here, see, it is the no, main branch image only. It will be um, not added the GitHub branch to the main branch. That's why the same image only it's coming. But it's Argo CD will be sync automatically. It will be done. Okay. Mhm. Now see my public repositories is the main branch. Private repositories in the my GitHub branch. But here the main branch only is there. If I want to change the main branch here to the GitHub branches, means here. Mm, yeah. See, in the Argo CD applications, record services, see here, previously it is the main is there. See, it's the main is there because it is the main branch application. Now I changed I check out the main branch and I came to the GitOps branch, right? Now it's showing like GitOps. Now I want to add this application for this file or to update it to the my GitHub Argo CD. That's why just I want to do simple one command. It will be add to that command. It's no make application changes to the GitHub flow. No, like Argo CD. I want to just apply Argo CD applications to the these clusters. I do only one this command. Mm, kubectl kubectl apply apply minus minus f no in the Argo CD. No, this is the GitHub branches. I will explain clarity. This is my code. No? This is the main branch. In the Argo CD, the Argo CD applications. The application, see, here main is there. Hmm? But I build the Docker images in GitHub branches. But here GitOps is there. Now I want to replace to this files to the my main branch. That's why I'm doing this small command. kubectl apply nsf argo cd argo cd argo cd inside all applications slash inside all files to replace, say, all files main branch files to the replace to these files. Got it? Now h minus n to the argo cd means the main branch argo cd to replace to the this four files. Yeah. See, just one single command will be replaced everything these files to that files and it will be done. It's done. Now you just refresh it. Just refresh. See, it's automatically, processing and syncing. See, it will change GitOps, GitOps, and GitOps, GitOps, and GitOps. It will be changing. It will be, see, health check, it's done. Catalog, it's completed. It's processing also, health check, it's everything, it's completed. It's processing everything. It's processing. Checkout services, code services, it's processing. It's only this one command. If you go there, you go to the my GitHub's branch. In the GitHub's branch, in the README file, I given the all steps with the with the steps. If you follow the steps, maybe you will get the clarity what I did. See, branching strategies. You know, branching strategies. Go the branching strategies. The last I mentioned somewhere. Yeah, see, to use main branch public repositories means you can use this one. It will be the main branch. But I want to use GitOps branches. It's production level. That's why I'm not deleting everything. I'm keeping everything. I'm check out the git checkout GitOps branches, and I'm running this one. I'm running this one. Only this command. Everything it will be GitOps branches. Everything it will be same. If you follow this document, you get the better clarity. Otherwise, if you watch this my entire video, not skipping, you'll get the clarity. I given the information also here. Get the clarities. Okay. I think it's completed. Yeah. UI it's completed, and orders it's completed, and catalog it's completed, checkout it's completed, health check it's completed. Now I will just refresh it. See, the most published secret shop by Ash. Hello everyone. Ash Academic, this is our YouTube channel. Like, share, subscribe, and thank you. Tonight, and I'm ordering again. Check out and ordering, updating. I shopped everything. Successfully, it's done. Now, I will make some changes in my code, UI code, and I will update it the code and I will push to the GitHub. Now I will see it will be working or not. It's a troubleshooting. See, GitHub actions done. ArgoCD sync is done. Understanding, detaching, configuration management is done. It's done. And application and accessing and testing also it's done. Everything done. Now operations and troubleshooting. Now these steps we are following. Monitoring application with the Helm, its metrics, and practicing the troubleshooting commands and reviewing the application logs and everything, and learning and everything, resolving the syncing the issues and everything. Now this is the step we are following. Now I will do some changes. If it is working or not, I will be check it. Okay. Mm, okay. Git pull. Yeah. Okay. I'll do some changes in where I will do changes. Yeah, in the UI, SRC, in the main resources, mm, templates, home.html. We will do changes here. Hi everyone, Ash Academic Live. Okay, I just Hi everyone, like, share, subscribe, Ash Academic YouTube channel. YouTube. Thank you so much. And I'll remove Ash, keep it Ash Academic. Again, I'm saving. See, again, you can see. Hi everyone, like, share, subscribe, Ash Academic YouTube channel and YouTube. Thank you. Secret shop by Ash Academic. Okay, I did this modified. Now I will commit it. Git add. Okay. Now git commit modify add new futures to the UI. Now git push. Okay. Now it's latest images. It is building now. Go to the actions. See in the actions in UI image only it is building. Not all images it's building. Only UI image only it is building. It is building. It's completed login the ECR and building the images. Building the image. Building the image. Once it is completed, update the Helm charts in UI and commit changes and post log in the ECR and configure AWS conditions and everything. We get it. Now, if you go and check Amazon ECR repository, Amazon ECR repository in UI, the latest image, see, is the latest image. Previously, it is one image, now it's two images. Commit 3CB10F0. See, 3CB10F4. This is the commit ID. It's done, it's pushed, and deployment summary. Yeah, deployment summary. See this commit ID GitOps and triggered by Ashwin formula and changes in UI. Deployment successful and it's done. Build and push to the Docker image to the ECR. Updated Helm charts and commits and everything here. Where it's updated means it is in SRC in UI. All right, we have to change the branch, right? In the main branch in UI, updated the here. See, previous is C4 1B ABB. Now this the image. Now we can check it. See, previous image C for this one. Now its image is 3CD. So it's the latest image. See, it is the latest image. Now go to the ArgoCD. See, detail store UI. It is processing automatically. It will be synced and it will be processing. See, it is the same application. Now it will be completed. It's automatically completed the images. Update the UI. Yeah, see, health check is done. Now, see, the most public secret shop by Ashwant Ash Academic. Hi everyone. Like, share, subscribe Ash Academic YouTube. Thank you so much for watching this YouTube channel video for first microservices application. See, phase 3 completed. Phase 1, phase 2, phase 3, it's completed. In the 3 phases, if we have any doubts, join our Telegram channel group and ping me the message. I or our community members will be reply very shortly. And phase 4, overall learning and outcome. Terraform as a code with the infrastructure as a code with the Terraform you learn. And Kubernetes cluster and managing and operation you learn. Containerization orchestration and microservices deployment done. GitOps is done. And ArgoCD operations done. AWS cloud services integrations, it's done. Now DevOps practices, you learn automatic deployment pipelines with the GitHub actions, it's done. Self-handling infrastructure concepts, it's done. Version controlling for the infrastructure as applications, it's done. Monitoring and observability practices, it's done. And security best practices for the cloud deployment, it's done. Ready to knowledge. Microservices architecture pattern. This is the entire 5 microservices architecture project. You learn cloud native application deployment strategies. You know, GitOps as a deployment, it's done. Kubernetes production level, entire application, it's production level. And AWS EKS management and operations is done. And end-to-end GitOps workflow implementing, you done. Entire applications, it's done. Grafana is done, Prometheus is done, Treasure Duty, Alert Manager is done, ArgoCD is done. I told you in the starting of the video what I will be covering on this video. See, in this video, I will cover Linux, commands I covered, Kubernetes I covered, Docker I covered, GitOps is covered, Shell script I covered, Terraform I covered, GitHub Actions I covered. All I covered in this video. Everything I covered. Now, yeah, one thing it's there. It is the certificate manager. HTTP certificate manager is there. You know, certificate manager, go to the SRC in UI. In UI, charts, value dot charts. If you go down, see here indirect NGINX, yes, SSL redirect changes to the false to the true. See here, I did a false only, true only. See, if in your case, if it is false means you can make it true. Do the true and domain-based access with the SSL. You know, my domain name is armula.site. You know, it is the SSL redirecting true. Hmm? And my site is ormono.site, and here replace with your email ID, because if we have domain, if you registered with this domain with this email ID, you will get the mail and if you have to accept that mail, it's automatically you will get the HTTPS certificate. Otherwise, it will be not get the certificate manager. And if you not get this, you can go and check the scam mails also. Like few days back, I checked. At the time, I got with my scam mail. I just accepted. I accept the HTTPS certificate also. Mm, And fine. Okay, everything is done. Manager, it's done. This mail ID have to do. This is the place. And if you do these steps, it's automatically you will get the mail. I will get the mail to access the HTTPS certificate. Okay, do these changes. It will be work 100%. Okay, and I hope I covered everything. Why I am not showing the HTTPS, because this I have my domain is expired. I don't have domain right now. That's why I'm not showing. Everything is done. Now let us start the destroying everything, because last time lot many members has messaged me, and now I'm destroying the services. At that time I'm getting a lot many issues. I don't know why you guys are getting the issues, but today's I will show you the entire destroying the process. You know, go to the git. Git my Now I'm changing to the my main branch only. Main branch only I'm changing again. Mm, you see now it's again it is syncing. It's again it will be syncing to the main branch. It's again it's syncing. It's a main. It's everything syncing. And I'm refreshing my application. See, again it's came to the normal only. And I will be okay now. Start the okay. These applications. Came to same application only. Now we will destroy the ECR images. I know I given the ArgoCD here in the last. Here I given some destroyment. Copy these 4 commands, paste it here. It's automatically it will be destroy everything. See, in the GitOps branch, I only used for the latest images only. I actually, you can deploy in the main. First, you can using the main branch. You can deploy the application. After that, you can go through the applications. Now, no, it's done. I deployed everything. Now you can just copy this. Can It will destroy everything. Main branch. It will destroy everything. Yeah, it started destroying everything. Okay. Now we can go to the ECR. Yeah. ECR repositories, private repositories, sorry, public repositories is nothing, is everything, it's clear. Now, AWS, yeah, it's, we need to delete it from this one. Okay. Now, say, this is the deleting now. We will wait some time. It will delete automatically. If you're stuck anywhere, you can join our Telegram channel group and message. Our community members will be reply you. Okay. Okay, this is our two branches. I will share this document. Otherwise, I will write one blog and I will post it in my LinkedIn, or I will share it in the Telegram channel, in this YouTube channel. This recording the video also. Okay, and this is the destroying. This link will be not work. It's not. It's still destroying. Wait some time. Yeah, it is started the destroying. It will take minimum 5 minutes only. See, creating it will be take. It's taken 1 hour, but destroying it will be taking 5 minutes only. Okay. So it's everything. It's destroying. See, with the step by step, everything it will be destroying. All it will be destroying. Root tables and everything. It is destroying. Okay, in our YouTube channel, in our YouTube channel, I taken the Red Hat, Amazon Red Hat OpenShift Nessa. See, these are the latest projects I deployed. See, in this full stack DevOps project, it's total 4 full stack projects I deployed. In this project also, it's a 5 full stack projects I deployed. And this is the Jenkins. You can go and refer, not everything. And database migration also it's done, and AWS S3 better is the latest tool done. You can go and subscribe it, and we can watch these YouTube channels. Okay. Guys, destroyed everything. Everything is destroyed. Okay. I hope you guys understood my this project. If you have still any doubts, you can ping me my LinkedIn and message reply. You see everything, every resource is deleted. I want to delete IAM role. I'm deleting the IAM role, detaching the IAM role, deleting. IAM role, it's successfully, it's deleted. Yeah. And it's my YouTube channel, subscribe. And now ArgoCD will not work because it's deleted, right? Yeah, it's deleted, it not work. And also not work. And I will share you this document in my LinkedIn. And this code also I will share in my LinkedIn and YouTube description also. Okay, guys. And thank you so much for watching this video. It's more than 2 hours video. Thanks for watching.